Have you ever wondered why a moving train feels still when you sit inside it? Why your speed changes when you ride a bicycle downhill? Or how scientists predict the motion of rockets and planets? Welcome to the world of motion, where every step you take, every car you see, and even the Earth itself, is constantly moving. In this chapter, we are going to explore motion and relative motion, distance and displacement, speed, velocity, and acceleration, uniform and non-uniform motion, motion graphs, and even the equations of motion. All explained in a simple, fun, and visual way. So fasten your seatbelts, open your mind, and get ready to move forward with physics. Let's begin our journey into motion. Have you ever noticed that sometimes things move, and sometimes they don't? In physics, every object can be in only two states. First, rest. Second, motion. An object is said to be at rest when its position does not change with time. For example, if a book is lying on your table and it stays in the same place, we say the book is at rest. Now, an object is said to be in motion when its position changes with time. Look at this picture of the bear. The bear is moving forward to grab an apple. Since the position of the bear changes with time, the bear is said to be in motion. So remember, no change in position equals rest. Change in position equals motion. Now let's understand something very important called a reference point. A reference point is a point we use to describe the position of an object. We never describe motion or rest by itself. We always describe it with respect to something. For example, look at this picture. A box is kept inside a moving train. To a person standing outside the train, the box appears to be moving. But to a person sitting inside the train, the same box appears to be at rest. Why does this happen? Because the reference point is different. So remember, motion or rest depends on the observer and the reference point. Now comes an interesting concept called relative motion. The motion observed by a person depends on the frame or location of the observer. This type of motion is called relative motion. Imagine you are sitting in a moving train. Another train passes beside you. You may feel that the other train is moving very fast, even if both trains are moving at similar speeds. This happens because motion is relative. Another everyday example is the sun and the earth. The earth appears to be at rest to us, while the sun appears to move from east to west. But in reality, it is the earth that is rotating. So again, motion depends on who is observing. Let us now understand relative velocity. The relative velocity of object A with respect to object B is given by velocity of A minus velocity of B. In simple words, relative velocity equals difference between their velocities. If two objects move in the same direction, their relative velocity is the difference of their speeds. If two objects move in opposite directions, their relative velocity is the sum of their speeds. This concept helps us calculate how fast objects appear to move. Let's understand relative velocity with two examples. Imagine two cars, A and B, are moving in the same direction along a straight road. Car A travels at 80 km per hour, and car B travels at 60 km per hour. To someone standing on the side of the road, the relative velocity will be 80 km per hour minus 60 km per hour equals 20 km per hour. This means that, to the driver of car B, car A appears to move forward at just 20 km per hour, even though it moves much faster relative to the ground. Now, imagine car A traveling at 25 meters per second while car B travels at 35 meters per second, but they are moving toward each other. From the perspective of the ground, the relative velocity will be 25 meters per second minus 35 meters per second equals 25 meters per second plus 35 meters per second equals 60 meters per second. In this case, the two cars appear to approach each other at a speed of 60 meters per second when viewed from car B. That's Module 1 of Chapter 8 Motion. In the next module we will learn about rectilinear motion, circular motion, rotational motion, oscillatory or periodic motion, and random motion. Till then, pause this video and solve these problems.